We're beginning a unit on trigonometry, mostly, dealing with triangles. So in the past, at ASM, we learned about right triangle trigonometry. You've used Pythagorean theorem and SOHCAHTOA in the past. If you're new to ASM, this might be new for you, but I'll teach it in this lesson. And then the new parts of this unit are for non-right triangles. We're going to learn something called the law of sines and the law of cosines. The first couple of lessons, though, will be what's called right triangle trig. So first, we'll talk about the Pythagorean theorem. So the Pythagorean theorem is for right triangles. So if we draw a right triangle, we have a 90-degree angle. We have three sides on the right triangle. We call them A, B, and C. It's very important that C is the hypotenuse, which is the longest side. Hypotenuse, longest side. Longest side. Great. A and B are called the legs. It doesn't matter which one you label A and which one you label B. And we know that A squared plus B squared is equal to C squared, as long as C is the hypotenuse or the longest side. That is the Pythagorean theorem. All right, so let's look at an example. We'll go through this fairly quickly because students are generally pretty good at Pythagorean theorem. The first example, the box in the figure to the right has a length of 80 centimeters. It's labeled for us down here, 80, a width of 60, labeled for us, and a height of 90. Great. This one's guiding us through by first saying calculate the length of segment AB. That's the green one. And then find the length of segment AC, which is also already drawn for us in the diagram, the red one. Part of this unit is going to be visualizing figures in 3 dimensions, which this example is not the hardest that we'll do for sure, but it's getting us into the idea of what we will be working with the next couple of units. So we can see below, the green line is the hypotenuse of a triangle. So if you imagine the green line, I'm going to redraw a triangle here. That 80, I'm going to put down here, 80 centimeters. 60 is the other leg of the triangle. Notice the right angle is right between the 60 and the 80. And then the green line is your AB. A, B. We can use Pythagorean theorem to find the length of AB. I'm going to call it C. I'm going to call it C because it is the hypotenuse, the longest side. If you're never sure which one the hypotenuse is, or if you mix it up, you can always turn the right angle into an arrow. A little trick. Right angle into an arrow, and the arrow always points at the hypotenuse. So then we can say A squared plus B squared equals C squared. It doesn't matter, 60 or 80, which one is A and B. So I'm going to say 60 squared plus 80 squared equals C squared. And then you can use NSolve to solve this, or you can solve it by hand if you'd like. We have 3600 plus 6400 equals C squared. You don't have to show this. I think you guys are pretty good at Pythagorean theorem, so we have 10,000 equals C squared. And so if you take the square root, you get C equals 100 centimeters. And C is the length of AB. So remember, we were trying to find AB, so I can say AB is 100 centimeters. All right, now I'll actually probably need that. Yep. So now if I want to find AC, that's the red segment here. That is also the hypotenuse, so you want to visualize. That's the hypotenuse of triangle ABC. So notice I'm going to redraw triangle A. That's this point here, B, and C. Hopefully you can see that the right angle is at the B down here. The right angle is down there at the B. I have C up here. I know BC is 90, and I just found AB is 100. So I want to find AC. I'll call it C again for the hypotenuse, or I could also avoid calling it C at all, and I could just say 100 squared plus 90 squared equals side AC squared. That's 100 squared plus 90 squared equals AC squared. That is what? 18100 equals AC squared. So if I take the square root on that side, I get the length of AC. Again, you can use NSolve to find that, but it should be the square root. You can use your calculator of 18100. And you should get that the length is 134.5. Or if you want to round to 3 sig figs, 135. But you can always leave more than 3 sig figs. So I'll say AC is 135 to 3 significant figures, centimeters. AC. Make sure that makes sense logically. It's the hypotenuse. Other two sides are 190, and it is longer than those two sides. So that confirms great what I expect it to be.